Bueno, el doctor Granada nos va a dar una conferencia y ahora nos dirá un poco los puntos fuertes que nos va a tratar.
Bueno, no, primero que todo, gracias por la invitación a Fernando, a todo el comité organizador y a toda mi familia española que la quiero tanto, la recuerdo con mucho cariño y acá. I'm going to start this talk now in English. I'm going to just switch to English. And the whole idea of this talk is to highlight perhaps the most important aspects of peripheral drug-coated balloons, but I'll talk a little bit about the technical features, talk about clinical perspective applications, and a little bit about the future. One thing that is important for the ones like myself and many of you guys that do peripheral vascular intervention, that actually people ask, what is different about peripheral vascular disease in comparison to coronary disease? And the answer is everything is different. I will be very careful about extrapolating some of the lessons that we learned in the coronary development and extrapolating those lessons into the peripheral vascular territory. I mean, number one, lesion length is very different in peripheral vascular interventions, as you guys know. When you go from the iliac area to the BTK territory, the lesions actually keep getting longer and longer and longer. The percentage of occlusions is significantly higher in peripheral vascular disease. Is very frequent that actually we find total occlusions in the peripheral vascular territory in comparison to the coronary territory as well. And one of the most important features is the presence of a significant amount of calcium in comparison to the coronary territory, especially in below-the-knee disease. So the requirements for local drug delivery in peripheral vascular interventions are different in comparison to the coronary territory. The use of potent antiproliferative drugs is desirable. That's the reason why we continue working with paclitaxel instead of limases. You need a prolonged drug residency in tissue. It's extremely important to maintain a biological effect over time. Need to minimize the presence of a chronically implanted device, and that's the reason why the operators, as Bernardo was talking about, prefer the use of balloons over stents. And something that is extremely important right now is to maintain and sustain the anti-restenotic effect. Something that is very different in peripheral vascular territory, as I described before, is the presence of calcium. Calcium is found universally in peripheral vascular disease, is located in different areas of the vessel wall. And there is a lot of discussion right now and work trying to determine the impact of calcium in local drug delivery and the use of drug-coated balloons versus stents in this vascular territory. Another important difference between peripheral vascular disease and coronary disease is that wrist stenosis occurs actually later. As you guys know very well, in bare metal stents, wrist stenosis peaks in humans around 6 months. That's the reason why we target clinical wrist stenotic trials at 6 months. Is 9 months in the presence of a drug for drug-eluting stents. But universally speaking, if you actually look at every single peripheral vascular disease trial, there is a peak of wrist stenosis that happens between 9 months to 12 months. This is extremely important because any technology that is developed for peripheral vascular applications need to take this into consideration and essentially sustain the vascular anti-restenotic effect as long as possible. I think actually the peripheral vascular intervention right now is one of the most active fields in terms of innovation and the development of new technologies. We have right now a significant amount of development pathways from dedicated plaque scoring balloons, the bulking technology, CTO crossing devices, plaque modification devices, scaffold stents, and local drug delivery. So it's going to be important in the future that we filter all this data and really understand the value of all these technologies in properly sized randomized controlled studies. Bruno may remember this slide very well, as we shared a lot of these sessions at this time. I want to point out that this is a slide that I created in 2009. And this is when actually a lot of people were challenging the concept of drug-coated balloons. We were talking about replacing stent-based drug elution, reducing restenosis, but the most important thing was to achieve this with a single dose application without the presence of a chronically implanted device. So I remember when I created this, the bottom line is that type of technology is a huge leap of faith. And it's actually very nice to see how the technology has evolved over time to a point in which right now the clinical data supports what at that time was a hypothesis. So this field essentially moved through completely different phases, as actually it happened in the coronary territory. The first phase was the phase of early skepticism. And I have to tell you, at the very beginning, a lot of people were concerned about the safety of the technology. A lot of people were concerned about the potential lack of efficacy of the technology. And it was very, very quickly, in a matter of several years, that properly done small first-in-human studies demonstrated over and over again the anti-restenotic effect of drug-coated balloons using all paclitaxel, but actually different excipients. And this is actually a list of the technologies that essentially in first-in-human clinical studies in relatively short lesions in the SFA territory actually showed a reduction in angiographic lumen loss and restenosis of 50%, around 50% or so. So we essentially checked that box. I think the credibility was there, but it's still, people said, small studies. We really need to actually move forward and understand better what this technology is capable of doing. Then we moved into a phase that actually I call mechanistic speculation. So people said, well, it works. We see it in a first in human studies with a small number of patients. But how is this possible that a technology that actually doesn't use a permanent implant actually essentially works? Right now, after multiple investigations and papers and reports from our group and actually multiple groups around the world, essentially we have proposed a mechanism of action that right now is somewhat accepted by everybody. The mechanism of action appears to be related to the deposition of particles on the surface of the vessel wall. These particles are actually captured by tissue, call it actually platelets, fibrin, and so forth. And then these deposits become the depot effect, releasing drug over time into the vessel wall. These are pictures at the bottom that essentially show the immunofluorescence pictures of particles adhere on the surface of the vessel right after balloon dilatation in porcine arteries. And you see here data from the Ranger balloon from Boston Scientific, essentially showing how these particles remain on the surface of the vessel, in this case, up to 14 days. So now we know that these particles are responsible for passive drug elution over time. The solubility of the particle plays a big role in tissue levels and pharmacokinetics. If, as you can imagine, if the particle that essentially stays on the surface of the vessel is very soluble, it disappears like a grain of sugar very quickly over time. If you have a particle that essentially dissolves slowly, is going to essentially maintain tissue levels over time. And this is what happens with these two balloons that have different type of solubility patterns. You see the impact balloon that you see essentially produces particles that dissolve very, very slowly. And you have actually the Lutonix balloon in which the particle actually dissolves a little bit faster. I am not really implying any potential benefits from one versus the other one, but essentially comes down to tissue retention levels and efficacy, and also the safety profile over time. So there's been a lot of work throughout the years trying to kind of fine-tune the solubility of the coating, which is going to affect pharmacokinetic levels over time. So the next generation drug-coated balloon features, will contain controlled crystallinity, reproducible drug content, predictable tissue levels, long residency time, and low particulate content. And these are actually features that companies are taking into considerations to develop the new generation drug-coated balloons. Then actually, right after the mechanistic speculation phase, we went into a panic phase, because everybody started talking about the potential of particulate release into the distal vascular territory. Part of the mechanism of action of drug-coated balloons is essentially to break and fragment the coating. Some of the coating remains adhered to the vessel wall, but some of the coating essentially goes downstream. And I have to tell you, if you do a direct microscopy analysis in every single drug-coated balloon, you will see that at some extent, all the balloons release a significant amount of particles downstream. And I think it's a universal fact, and I don't think anybody can really say that their balloon doesn't produce particles. But the main question is, what is the biological effect of these particles, and if really actually that really matters? That's the main question. Some reports actually at the preclinical level have demonstrated that these particles do actually get stuck in the distal circulation. And you see here, this is a study published by Dr. Virmani's group that essentially shows differences between a highly crystalline coating and a less crystalline coating in an experimental model. And no question that if you have more crystallinity, the particles are going to stay in tissue for a longer time, and it's going to be easier to identify those particles in tissue. The interesting thing is, if you put every single pivotal SFA study into a single slide like this, you will see that the 12-month reported thrombosis and major amputation rates is close to zero in every single study. So really, even though we can speculate that particulation does occur and that happens in the SFA territory, at the present time, I don't really think there is any evidence that that clinically is important. But it's still, the question remains, does distal downstream particle embolization impact wound healing and could affect clinical outcomes? What we know is in the SFA territory, there are no safety considerations. But what about if a patient has an open wound? This is a very interesting study that we did in collaboration with Medtronic, in which essentially we suggested to develop a wound healing model to test this hypothesis. So essentially, as you can see here, wounds were created artificially with a punch biopsy method. 3 ulcers were actually performed or induced in the pig, and a drug-coated balloon was essentially ballooned above the wounded territory in 1x and 3x configuration. What is actually interesting to see is, if you see the PTA group versus DCB 1 inflation versus 3 inflation, you pretty much do not see any impact in the healing effect up to 28 days. If you actually look at the scoring system that we use to essentially evaluate wound healing, you would see the PTA group and the DCB1 group, they track the same in terms of healing. And I would say, just to remind people, 4 is actually no healing and 0 is actually complete healing. You actually see that the DCB groups essentially tracked in a very nice way, not showing any signs of delayed healing. Which is interesting is, when you measure paclitaxel levels around the wound, paclitaxel was present, higher in the 3 times group versus 1 time group. But it's interesting to see that particles were recovered, paclitaxel levels were present, but healing was not delayed. Again, this is an experimental model, no evidence of disease, no compromise of microcirculation, but it's very interesting because we were able to prove that paclitaxel did not affect wound healing in this experimental animal model. So where are we going from here? First generation DCB coatings were highly crystalline, had a high content variability in terms of dose, had inconsistent tissue levels, but actually resulted in a high residency time, but also high particular content. New generation drug-coated balloons are trying to decrease the solubility of the particle a little bit, controlling the paclitaxel crystallinity, and actually also trying to protect paclitaxel to avoid the toxic effects of the drug. But one important characteristic of all these balloons are trying to reduce the balloon paclitaxel coating content. Why this is important? All companies of new generation devices after the Impact Admiral balloon and the Medrit balloon that you guys remember very well moved very aggressively from 3.5 micrograms to 2 micrograms universally. They actually use different excipients, so the pharmacokinetic profile of each balloon is actually different. This is important because we have seen over and over on the experimental setting and also the clinical setting that, as you could potentially expect, there is actually a dose escalation effect. This is a study that actually we did a long time ago that compared the same coating with the same pharmacological characteristics, comparing 3 versus 1. This is on the MedRat times. And you're going to see here, as you can see here, there is almost 50% difference in neointimal formation when you compare the 1 microgram versus the 3 microgram. So dosing companies have to be very careful because it's going to be a potential impact on pharmacokinetics as you reduce the dose from 3.5 to 3 and 2 micrograms per millimeter squared. But now it's not just about dosing, it's also about crystallinity of the coating, and it's also about the particle solubility to be able to stay over time. You actually see here, when you decrease the 3.5 micrograms to 2 micrograms, there is a slight impact on neointimal proliferation, but also when you see balloons that are able to maintain the level of crystallinity that is needed, in this case, the Stellarex balloon, you potentially can achieve the same degree of anti-restenotic effect without really affecting efficacy. So in the future, it's going to be a fair amount of fine-tuning between dosing and crystallinity to be able to reduce the overall number of particles that will be sent downstream following balloon inflation. So then we moved, as it happened in the coronary territory, into a data-driven field in which evidence-based medicine is extremely important. Randomized controlled studies will determine the safety and efficacy and performance of these technologies. These are the 3 balloons that right now have FDA approval and have randomized controlled data. You actually see here that universally speaking in randomized controlled studies, relatively simple lesions, there is a reduction in risk stenosis in actually every single technology up to actually 12 months, which is the peak of risk stenosis, which is very encouraging for all drug-coated balloons technology. The curves actually start to separate when you actually go beyond 1 year. And you see here in the Levanto trial with Lutonix, the difference delta was around 16% in patency rate at 1 year, decrease of 5.6% at 2 years. And when the impact actually went from 31% at 1 year, remain actually around 28% at 2 years, and it still is in the mid-20s at 3 years. Very recently at Viva, the 2-year primary patency rate for the Lumitate balloon was presented. And again, you actually see here 75% patency rates at 2 years. So you start actually seeing that improvement continues to remain stable, up to 2 years in actually some of these balloon technologies. What about the BTK territory? This has been actually still a controversial application for drug-coated balloons, full of actually small randomized controlled studies that essentially show controversial results. This is one perhaps of the more controversial studies, which is the Impact Deep. Everybody had a lot of excitement about this trial because it was truly randomized of the Impact balloon for BTK application. As you can actually see here, Restenosis did in favor drug-coated balloons, TLR did in favor, slightly actually drug-coated balloon, but major amputation actually was borderline on favor of the PTA. There are many, many explanations for this failure from the technology point of view, dosing point of view, platform point of view. But the reality is a negative trial is a negative trial, and essentially slowed down the development of BTK applications for drug-coated balloon. This is a summary of some. I know there are newest trials, but it's important that actually to see that the data is somewhat, in a way, controversial. You see primary patency actually, in a way, is not really that bad for all these trials. You see TLR, and again, is not really that bad for all trials. The important thing is when you start actually comparing with PTA results, is not really as good as the data that we consistently got in the SFA territory. This is the BioLux randomized trial, again, for BTK, comparing the PTA balloon catheter versus the drug-coated balloon catheter. And again, TLR, patency loss, very, very similar. And again, adding more to the neutral data that we have seen so far in the BTK territory. Now we're moving into the phase of technology adoption. And the most important thing I heard in the background when we were talking about balloons and stents, the competitive landscape, because drug-coated balloons are not really alone. And one of the big determinants of success in the future is going to be the presence of calcium. This is a very nice slide that actually I took from Viva and modified, that essentially shows the impact of calcium presence in restenosis, and no question about it, that as the calcium percentage and deposition increases, actually the percentage of angiographic restenosis and patency decreases. So this is a lot of questions about, are drug-coated balloons the right tools to essentially treat this type of patients? There is already some experimental data from our lab and from LSR Edelman's laboratory that essentially suggests that modifying or actually removing the calcium from the artery may improve tissue uptake of paclitaxel and can potentially improve clinical outcomes. So there is going to be a lot of trials developed and discussions about the concept of the bulking atherectomy and lesion preparation in relationship to drug-coated balloon technologies. And the technology expansion of drug-coated balloons in the peripheral vascular territory is going to depend on many, many factors. One is on the expansion of clinical evidence. Doing randomized studies in long lesions, in in-stent restenosis, in highly calcific devices, and the use of ancillary devices. Also, the expansion into new clinical applications. The most important one is below the knee. We need to try to figure that out. We need to essentially move forward with technology evolution, longer tissue retention rates, lower concentration balloons, and actually an emerging field that is quite interesting, the field of liquid-based drug delivery. And we need actually also new technologies. And there are a lot of programs right now using alternative drugs, local delivery of biologics, and alternative delivery methods. You see here one of the biggest competitors of drug-coated balloons, which actually will be drug-eluting stents. You guys know the Silver PTX, which is a polymer-free device, the Alluvia for the SFA, that is actually polymer-based, and at least two dedicated platforms that right now at least are somewhat in use for below-the-knee applications, drug-eluting stents. And there is a lot of discussion about the competition potential benefits between using a polymer-based system versus polymer-free system. As you actually can see here, the polymer-free, such as drug-coated balloons or the Silver PTX, you actually upload a lot of drug into the artery, and then whatever remains on the vessel surface starts to decrease over time in a way that is not controllable. In a polymer-based delivery system, either with balloon or actually a stent, you actually achieve a more consistent tissue levels over time. So the main question remains, and this is actually for future randomized controlled studies, is if polymer-based devices could potentially improve the outcomes of polymer-free devices in the future. This is a study that was recently published by our laboratory that essentially compared the Alluvia stent, the silver PTX, and BMS control in an experimental model of a high cholesterol, hypercholesterolemia. And it's actually interesting to see that with the polymer method, with Alluvia, you see lower levels of neointimal areas, lower levels of neointimal thickness, and actually less angiographic stenosis. So, potentially speaking, in the future, polymer-based devices could potentially improve the outcomes of drug-coated balloons, but we're not going to know this until we really have randomized controlled data. This is actually one of the studies that were presented before, overlapping the curves of the Majestica trial, which is a polymer-based paclitaxel stent system, the Alluvia system with silver PTX, essentially showing potential differences in outcomes between the systems. And in the future, this is going to be very relevant for the development of randomized controlled studies. Another potential innovation that is relevant for drug-coated balloons is the use of dedicated stents. This is the TAC endovascular system that is a form of small stent-like units. So as you can imagine, it's got the potential to essentially follow drug-coated balloon angioplasty. And when you see a dissection or when you see lumen loss, you can actually go and tack that area with this small stent. So it's kind of the best of both worlds, in which you actually use local drug delivery, leave nothing behind, but then just use small units of stents to tackle the problem related to biomechanical failure or dissections. And this is actually a slide that describes the evolution of local drug delivery. As you guys know, there's been a lot of work, still a lot of work with paclitaxel nanocrystal encapsulation. We have a lot of work right now with liquid forms of paclitaxel that actually aim to essentially reduce particulate formation and achieve a biological effect. Different drugs like the crystalline sirolimus drug-coated balloon, at least 2 or 3 programs, and encapsulation of drugs with nanoparticles such as the Caliber system. We recently published, actually this month, the first in-human experience in stent restenosis in JAK interventions. And this is just a proof of concept of this balloon that uses a nanocrystals with sirolimus to prevent restenosis. And this is a balloon that potentially can be used on the BTK territory with a new compound such as sirolimus in patients with BTK disease. And this is new data that is being emerging and presented at Link and recently at Viva with a Mercator balloon delivering dexamethasone in the adventitia of the vessel wall. So as you can imagine, you're not leaving particles behind, you're not sending particles downstream, and instead you can use this delivery system to deliver large amounts of drug in the adventitia. Then you do your angioplasty, and in small studies in SFA and BTK, actually a beneficial effect in restenosis has been demonstrated. Obviously, this needs to be taken into consideration in perspective with the paclitaxel drug-coated balloon data. So in conclusions, we have a strong clinical foundation supporting the use of drug-coated balloons in the SFA territory when clinically indicated. I think that we can check that box. Also, the mechanism of action appears to be very clear right now. The specific coding features clearly impact clinical outcomes. 1-year efficacy data is promising for all drug-coated balloons. However, sustainability of the clinical effect will drive clinical adoption. The downstream paclitaxel particle embolization is a real phenomenon. However, the impact of paclitaxel tissue residence in wound healing in the presence of appropriate distal vessel runoff may not be of clinical significance, especially in the SFA territory. No question, the local drug delivery field continues to evolve, and future investments in drug-coated balloon iterations are worth it, as long as sustainability of the clinical outcomes can be maintained over time. So thank you very much for your attention. If you have any questions, I'm happy to take any questions from the audience.
Muchas gracias, doctor Granada.
¿Alguna pregunta?
Juan, ¿me oyes? Buenos días, soy Fernando.
Hola, Fernando.
¿Cómo estás? La verdad es que el otro día, hace 2 días, ¿no?, cuando en tu nueva posición de CEO del Cardiovascular Research Foundation, que yo creo que eso ya nos explicarás un día lo que es, le dijimos a tu nueva secretaria, entiendo que teníamos esta cita contigo, casi le dio un ataque y dijo que era absolutamente imposible. Entonces te agradezco el esfuerzo para la conexión, te doy las gracias por el interés y el apoyo que has dado siempre a este curso y quizá antes de que pierdas contacto, no con la clínica, que a lo mejor ya hace tiempo que te cuesta más mantenerlo, sino incluso con tu actividad de investigación a nivel básico, porque está claro que tú has empujado el field de una forma importante y eso lo saben todas las compañías que han probado los dispositivos de una forma científica, crítica en el Skirball. Mi pregunta en concreto, reconociendo que yo soy una persona que de enfermedad periférica arterial sé muy poco, ¿qué hemos hecho mal en las coronarias, en las lesiones de novo? Tú has explicado muy bien cómo la enfermedad arterial periférica es muy diferente de lo que vemos en las coronarias. Sin embargo, a nivel de animal, a nivel básico, el balón de plaquetaxel, el balón de sirolimus, funciona en tejidos coronarios. Esta mañana hemos tenido una mesa donde básicamente la conclusión crítica al final es que, bueno, pues se puede hacer, pero no tenemos evidencia de que en algunos pacientes, en algunas lesiones en concreto, este balón sea de una utilidad tipo nicho. Entonces, yo no sé si es que la patología arterial periférica es completamente distinta, como tú has dicho, o simplemente que los stent farmacoactivos de última generación funcionan muy bien en las coronarias y quizá por eso no funcionan tan bien en la periferia. ¿Qué tenemos que hacer en las coronarias? Y perdón por irme a mi campo, una pregunta ¿qué tenemos que hacer en las coronarias? ¿Qué tipo de estudio tendríamos que hacer para demostrar la utilidad de estos balones en algún paciente en concreto? Demostrarla de forma fehaciente. Gracias, Juan.
Fernando, gracias por la pregunta y de nuevo es un placer trabajar con ustedes y España es un país que lo llevo muy cerca de mi corazón y verdad que cada vez que puedo les ayudo, colaboro y quiero seguir trabajando con ustedes. Tu pregunta específica, Fernando, es acerca de lo que estabas hablando de qué hacer en las coronarias, en qué situaciones para mejorar qué. Que esa parte me quedó como partida.
O sea, lo que quiero preguntar, mi pregunta en concreto es en lesiones de novo, no en restenosis intrastent, que tenemos mucha información, en lesiones de novo en coronarias, el valor de los balones farmacoactivos, la evidencia con respecto a estrategias establecidas como el stent con fármaco no acaba de cuajar. La pregunta es ¿por qué?
Mira, ¿tú quieres que responda en español o en inglés? Fernando.
Whatever is easy for you.
No, es de acuerdo como tenga la mesa, que no sé cómo la tienes. Pero mira, te voy a decir que la forma en que yo veo el problema del tratamiento de lesiones de novo con balones medicados. Si tú comparas 1 a 1 el grado de trauma vascular y la restenosis resultante en un balón versus un stent, tú vas a ver que universalmente, y esto es algo que la gente muchas veces no sabe, el trauma vascular y la restenosis es mucho más alta cuando tú usas un stent que un balón. Si tú comparas 1 a 1 en una arteria de un cerdo, el efecto de angioplastia con balón y stents, los grados de trauma vascular y restenosis son mucho más altos en el grupo de los stents. Pero ¿cuál es la gran diferencia? La gran diferencia es que la cantidad de lumen residual que se alcanza con un stent es mucho más grande que el lumen residual que se alcanza con un balón. Entonces, una de las grandes limitaciones de la approach de balón solo para lesiones nativas es que tú puedes entregar la droga, tú puedes mantener los niveles tisulares a largo plazo, pero tú no estás encargándote de tratar lo que es el efecto biomecánico. Y el efecto biomecánico de los stents es algo que nosotros no podemos olvidar. Dentro de la prevención de restenosis en pacientes, sobre todo con lesiones complejas, largas, con gran cantidad de calcio y tejido necrótico, mantener todo ese tejido contenido detrás de una malla es muy importante. Entonces yo creo que no es solamente el efecto farmacológico, que también es importante, porque con stents tú puedes tener un efecto mucho más reproducible de la liberación de la droga, pero es difícil mantener un lumen mucho más grande que sea cuantificable cuando tú utilizas balón solo comparado con los stents. Entonces, te lo digo, primero que todo hay que cambiar el mindset y nosotros tenemos que aceptar que no todo es solamente angiographic lay loss, que eso no es significativamente lo único que determina el éxito clínico. Número dos es evaluar muy bien el grado de cicatrización vascular. Pero número tres, también entender que el efecto del scaffold es muy importante en la cicatrización del vaso a largo plazo. Entonces, para mí, ese es el gran handicap de los drug-coated balloons, cuando tú ya llegas a trabajar en territorios que son hostiles, con lesiones muy largas, calcificadas, con grados de disección mayor cuando tú terminas el procedimiento, etcétera, etcétera.
Any question from the floor? Dr. Granada, I would like to know your criteria selection in order to have the best characteristics in a drug coating balloon. Nosotros a veces tenemos la oferta diversa de la industria y queremos saber qué es más importante en la selección. Drug carrier, la tecnología de plegado, la dosis del balón. Give us some something.
Mira, es una pregunta muy importante. Es una pregunta muy importante. Hay una cosa que es importante discutir. Cuando hablamos de la dosis, como operadores, como gente que utiliza esta tecnología, es importante que ustedes entiendan que el concepto de 3.5 microgramos, 2.5 y 2 microgramos en realidad no significa nada. Solamente significa la cantidad de droga que está depositada en la superficie del balón. Hay veces algunas tecnologías la deposita dentro de los pliegues, otras están circunferencialmente. Lo que es realmente importante, si tú me preguntas como operador, es la característica del cubrimiento en cuanto a durabilidad y en cuanto a la solubilidad de la partícula que se relaciona con los tejidos tisulares de paclitaxel y que se relaciona con el pronóstico clínico del paciente. Si hay una cosa que está clara en este momento, es que la cristalinidad de la partícula, balones que tienen alta cristalinidad, resultan en tejidos tisulares más altos y resultan en pronóstico clínico mucho mejor a largo plazo. Una cosa que es muy interesante, como yo puse en mi diapositiva, es si ustedes miran los resultados a 12 meses, yo creo que es justo decir que todos los balones tienen un performance que es muy parecido. Pero cuando tú empiezas a extender el seguimiento a 24 y 36 meses, tú ves que las curvas empiezan a cerrar en algunos de estos balones. Entonces, para mí, obviamente, los datos clínicos es lo más importante para seguir. O sea, nosotros seguimos nuestras líneas de manejo basados en estudios randomizados a largo plazo. Pero cuando es acerca de las partes técnicas son las cosas que es más importante, es entender la farmacocinética del balón, porque eso es lo que va a determinar el pronóstico clínico.
Muchas gracias. ¿Alguna pregunta? ¿Alguna pregunta? Estamos un poquito pasados de tiempo. Yo seguiría preguntando muchas cosas, pero yo creo que si no vamos a repercutir negativamente con los colegas que vienen detrás. Y entonces simplemente dar las gracias al doctor Granada, a nuestros dos ponentes aquí que están en presencia física. Muchísimas gracias por sus intervenciones tan interesantes y gracias a la organización por habernos invitado.
Gracias. Un abrazo a todos de nuevo y gracias por la invitación.